And we welcome in team number 6328, Mechanical Advantage, coming in from Massachusetts. This team competing week one, so very excited to hear about how they're getting ready for a week one competition. We all know the nerves that go into a week one event sometimes, but I think 6328 is going to wow a lot of people. Some great progress so far and some really cool things to show here. So we have Max and Jonah joining us from that team. And guys, do you mind just introducing what you do on the team?
Yeah, I'm Jonah. I'm a junior and I'm our software lead.
My name is Max, and I'm the lead technical mentor.
Well, you guys have a lot of stuff that you sent me ahead of time to take a look at. So I want to just dive right into that because there's a lot of really neat stuff to talk about. Let's start out with your CAD on your robot here, and we're going to bring that up on screen and give us a little bit of a walkthrough of your robot and some of the general concepts behind it. Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. First Updates Now is supported by Kettering University. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental U.S. scan the QR code and complete the form by the date on screen and receive more information about Kettering.
Sure. So I don't think we're doing anything too radical this year. I think this is, in a lot of ways, very similar to the designs that we'll see from a lot of other teams. Has some heavy inspiration from the tall robots of 2020. Our intake is somewhat of a virtual 4-bar, which is inspired by 1678's 2020 robot, designed to be flexible and compliant for how brutal we expect this game to be. And then our hopper singulator is just 2 Omni wheels to basically center the ball into our tower, which then feeds into our flywheel shooter, which is, again, the somewhat normal 6-inch Coulson wheel main flywheel, and then the 2-inch wheel top roller to try to have more consistency and reduce some of the backspin, which it seems like is a positive thing for making sure the balls actually stay in the goal once you get them in there. We're still experimenting with that a little bit, honestly. It's designed, we're basically at the point where we're just kind of going to adjust it to see, but somewhere around the 2/3 mark, so that it's above the center crown, so that it hopefully prevents the balls from just bouncing and flying upwards, if at all possible. Yeah, so it's a single stage telescoping with powered by 2 Neos, not pictured in the CAD because we haven't actually finalized it yet, but we're trying to go for high and traversal using a somewhat standard like 2013 style tilting handoff mechanism, like you've probably seen a lot of other teams doing. But that is the one part of the robot that is not finalized yet and still needs some design and testing work.
I just want to comment, by the way, I love the Open Alliance logo that you guys are planning on doing here. Is that going to be like laser engraved, or what's the thought process on that?
So that's actually a 3D printed part.
Okay.
So it's just embossed into the hood.
Nice.
Cool. So we've seen this really great CAD design. It really looks really complete. How far along are you in terms of actually putting it all together and making it real?
So everything, yes, this is a photo that I took approximately 10 minutes ago. So the shooter structure was finished a few days ago, and then the intake was just put on today, and we're finalizing manufacturing the climber parts as we speak.
And so what's your time schedule look like between now and a couple weeks from now?
Yeah, so the goal is to be mechanically complete in the next few days. We've been somewhat trading off with software, doing the bring up of the actual robot. And then the goal is to be done for next week so that it's just practice, auto development, and fine tuning.
So we have a lot to show as well too from software, as you mentioned. I know you sent me some autonomous modes that I'm very excited to show off on behalf of your team. So let's bring those up on screen. You got 3, 4, and 5 cargo autos. So I think we work our way up a little bit. So let's start with the 3 cargo auto. We'll let that play a little bit and give us some narration behind some of the strategy behind it, and then the actual programming that's gone into it as well.
Yeah, so we want to get started on developing these auto routines as quickly as we can so that we can work through any potential difficulties. Week 1, we had our motion profiling system done, and then this was our chance to really play around with our practice bot, which has the same drivetrain as the final robot. So the 3-ball auto is relatively simple, starting on the lower tarmac here, picking up the 2 cargo right around in that circle there. The nice thing about this one is we have enough time that the robot can come to a complete stop and we can shoot. Obviously, at this point, we don't have an actual shooter to be testing with, but in this case, the software is controlling the shooter. It's running all of the correct commands. There's just no hardware attached. We can look at from the log files it produces the times in the sequence that it's running the shooter and confirm that all of that is working now. Okay, so then the 4-ball auto, this gets interesting because we add in the tarmac. So here's an opportunity we can check that the odometry is accurate, even over a fairly long run between the first shot and the terminal, sorry. One of the things that we don't have on the practice bot that we think will be very helpful in autos later on is a limelight. So we've done a lot of work. We talked previously about the work we've done with the limelight and maintaining accurate odometry with that. So we're hoping that as we're driving quickly across the field, we can use the limelight to correct our position and maybe get a little more aggressive with the acceleration, speed some of that up.
Yeah, I was going to ask about that because, using odometry with the type of drivetrain you have, there's obviously going to be some drift. I mean, there's going to be drift no matter what, but I think you're more prone to having more drift with this type. So yeah, I think using the limelight is a great solution for something like that. What are you actually doing your programming for your odometry in?
So all of our code is written in Java. So the odometry code is just using tools that are built into WPILib for calculating odometry. We've enhanced it obviously a little bit with the limelight. We've written some custom software to process coordinates that are retrieved from the image and turn that into odometry data. But none of that is doing anything more than pretty basic trig and curve fitting.
Well, let's hop into your 5-ball here. And one thing I'll note that nobody will be able to tell is all these videos you sent me, I think, are under 15 seconds. At least this one is 14. So it's not like, this is very doable for your team, right? At least from a time perspective. But talk to me more about the pathing for this one.
Yeah. So with the 5-ball auto, this is where we start to really run into 15 seconds. And we were considering 2 possible paths. So one is you immediately shoot the ball that's preloaded, collect the 2 from around the tarmac, shoot those, then get 2 from the terminal, because 1 is provided by the human player. We've seen a lot of teams do that. We went with a different approach where we collect 1 cargo from around the tarmac, then shoot 2 to start. The reason for that is that it means that we don't need to do a tricky maneuver between the 2 balls on the edges of the tarmac, which requires doing a very tight turn that would be difficult on a differential drive. But we're able to keep it very smooth without any sharp turns doing this sequence. And as you see from the video, we believe we'll have enough time for that. We're still working with exactly how quickly we can feed balls and when we need to start shooting. So we might need to carefully time it. So for example, we start shooting as we're decelerating, but we'll cross that bridge when we get there.
Yeah, because you still have some travel time with your indexer, right, to get into your shooter.
Yeah.
So all that's being added in. Sorry, Greg, go ahead.
No, I was going to say, so your shooter right now, it looks like, I think a lot of teams are biasing themselves to try to shoot from the fender What's the range that you can actually shoot to the target from? Because I think that'll play a big amount into your auton. You know, if you can take those last two shots from, you know, like a downtown or like starting line distance, as opposed to driving all the way back up forward, like you showed in the videos.
Yeah, definitely. Every inch farther that we can shoot is an inch less that we have to drive, which is very nice from our perspective. The way the autos are set up right now, we're um, positioning the robot roughly in the middle of the tarmac, which we're pretty sure we'll be able to shoot from. And we're still experimenting. Once we spin up the shooter, we'll have a better sense of how far away we can get and how accurate we can get. So we can maybe shave off some time that way.
And do you have an adjustable hood on this robot, or is it just a one angle hood?
Currently, it's a pneumatic adjustment, but the second angle is mostly for making the logo like little bloop shot more consistent. That was somewhat of a conscious decision for week one, is to be more or less static, with this being one of the obvious growth areas going into our second event and hopefully onward, of actually having more adjustability built in there so we can shoot from farther away.
Yeah. So, I mean, but strategically, just kind of thinking about this, because you're going into week one, are you thinking that you're going to have a 5-ball ready to go week one, like first qualification match, full send? Or is that something you're working towards?
We're going to do our best to get there. Obviously, as I've said before, we want to stick to the autos that are reliable for us, but we're hoping with the robot getting done in a timely manner, we'll have enough time for testing, and that's our goal.
The plight of the programmer, right? So I hear you. I do want to take a question from chat, by the way. Edward5 asking that since the robot wasn't fully built in the auto clips that you showed, how do you use simulation, or how do you build stuff without, or test stuff without actually being able to like test it really in person?
Yeah. So actually, as part of the structure of integrating our logging framework into the code, the hardware interaction in all of the subsystems is separate from all of the logic that controls what's happening. So we've set up for key subsystems like the drive and the flywheel simulated implementations, which approximate the physics of the real robot. So we can use that in a couple of ways. First, we can just plug in all of the simulation classes and run the entire autonomous routine on a computer. And that makes it really easy to tune things, make sure everything's working properly, we have the sequence right, all of the basics. Plus, one thing that was really useful in those videos that we just watched was on the practice bot, we don't have a flywheel, but an important part of the auto routine is waiting for the flywheels to get up to speed and making sure they get up to speed in time. So in all of those videos, the Rio was running with the simulated flywheel implementation. So we can watch from the log file what it predicts the flywheel speed is throughout those routines, and we can make sure it's waiting for it at the correct points.
A couple other things I just want to ask about. I was just going through your build log that you had on Chief Delphi. And by the way, all these teams tend to have pretty good build logs. 6328, I think, is one of the better teams that really does a great job of just documenting everything. So I'm going to put you on the spot. So I'm not sure if this is your area expertise, but you posted a motor test rig from before in a design for that. Can you just talk to me a little bit more? We'll put it up on screen a little bit more about how you're using that and what you're learning from it, and what maybe other teams could take away from something like this as well.
Yeah, so there are a lot of times that we're prototyping that it's really important that we can just run a motor, and usually we don't need to worry about closed loop control or brake mode or any of the fancy things that I tend to spend my time worrying about. We just need to run it open loop, and this is meant to be a simple and a safe way to do that for both brushed and brushless motors. Thanks.
Yeah, this was somewhat motivated after like last year testing our shooter prototype with 3 laptops all plugged into Spark Maxes with the hardware client, and like almost dropping them on top and being hit by balls and things. This has been pretty invaluable for testing prototypes. We just kind of drag it around. It was on one of the kit bots powering an intake at one point, and it got tons of use on our shooter. So I think there's tons of different ways to do it. At the low level, it's basically just a PWM generator. And I think it turned out very cool. And it has some extra safety features of actually fusing all of the circuits and such, so that we're not just kind of sketchily plugging things into batteries. So I definitely think it's a very cool off-season project that's useful in the season and can teach some cool electrical and wiring skills for other teams.
One other video that you had on there, when we had you on a few weeks ago, you showed off a little more of your of the simulation we were talking about before, of actually showing it, and I just want to bring that up on screen as well too. Is your auto simulation they had as well? Do you mind just maybe diving a little bit more into what we're seeing on screen and how you utilize this?
Yeah, so this is what I was talking about before, running the full auto routine in
Yep.
simulation. And what we're looking at here is actually it's a recording of Advantage Scope, which is the app that talks to our logging framework. So this is set up, we can open a log file, we can connect to a robot, or in this case, connect to a simulator. And it gives us a bunch of different ways to visualize data coming off of the robot or wherever the code is running. On the right is the odometry data. So this is from the drivetrain simulator. And on the left is a line graph. So we can see there's a yellow line and a purple line. Those are the simulated speeds of the two flywheels on the robot. And then on the bottom, it's pretty small, but the orange and the blue are the times that it's trying to run the intake or it's trying to shoot. Even though we don't have simulations of simpler mechanisms like that, we can still check that it's running them at the correct times and sequencing them.
This is a great demo that just show teams as well too. And I think that answers that question really well from before, from that simulator. So really cool that you guys are showing this off. I love. I mean, I know it's the whole point of the Open Alliance, right? Is to be very open with that. But I think this is a great example. Especially for people like me who are very visual on that. This helps me understand a lot more for that. I do want to grab a couple of quick questions from chat before we wrap up here. I'm going to read these kind of verbatim, so bear with me on here. Adver5 asking in regards to your shooter, what is the gearing on the primary flywheel versus the top flywheel?
So the primary flywheel is geared down 2-to-1. We found that we didn't need to be super fast this year, and it's a 6-inch wheel. And then I'm not exactly positive what the 2-inch wheel is, but it's geared to roughly match the surface speed of the large flywheel.
And then last question I'm gonna grab here, and this one I might paraphrase this a little bit. From Hazard Boy 1 says, "What was your original design choice?" So I'm guessing they're asking, like, has anything changed from your original design to what you have now?
At one point we were entertaining. I think last time we were on, we showed the crazy double catapult prototype.
Yes.
That was very fun. Sadly, at least for us, it didn't seem to be particularly practical. I still really want to see a team that pulls one off. So I don't think the design has changed too much from the beginning. It was mostly all kind of small iterations along the way.
I will say I have seen a couple teams send me double shooters, so I think we'll see some of those. I'm not sure how many catapults we'll see necessarily, so it'll be interesting. Last one, I know we answered this before, but we'll just take this as a question just so this person can hear it. Nito3K asking about your climber. Can you just elaborate and give a little bit of paraphrase once again what you're doing for a climber?
Yeah, so it's a single stage telescoping. It's currently using like 3D printed blocks to slide on. Some of which have bearings on dowel pins pressed in them, constant force springs to pull it up, and then it's winched down. There's basically two Neos through the max planetaries geared together. And then there's a PTO dog gear basically to act as a brake for the system for when to hold it down when it's disabled and after the match.
All right. Well, 6328, thanks a lot for coming on, answering some great questions as well, too. Looking really forward to seeing your robot compete week one. I mean, if it's anything like your CAD and you get that fully assembled, I think you're going to be in great shape, and your team has done quite well in the past. So looking forward to see how the performance is going to be. So good luck going to week one and, of course, the rest of the competition season. Thanks to Kettering University for their support of this video. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental US, scan the QR code and complete the form by the date on screen and receive more information about Kettering. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in First are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.